Welcome back, ladies and gentlemen, to the 2024 FRQ questions. Right now, we're going to be going over three of them. The three questions that actually overlap between AB and BC. So if the order's a little funky, that's why. All right, we're going to start with number one. The temperature in a coffee cup is modeled by a decreasing differentiable function. The temperature is measured in Celsius, and the values are shown. Approximate C prime of 5. All right, if you want to approximate C prime of 5, we're gonna have to do an average rate of change, and we're gonna be using the values closest to 5. So C of 7 minus C of 3 divided by 7 minus 3. That's gonna be 69 minus 85 divided by 4, which gives us negative 16 over 4, and that gives us a final answer of negative 4 degrees Celsius per minute. Now, to be safe, I would recommend that you do take your answer and put it in a sentence, right? Put it into the context, whether or not it's saying it. So, at T is equal to 5 minutes, the temperature of the coffee is decreasing at a rate of ... negative 4 degrees Celsius per minute. Use the left Riemann sum to approximate the value from 0 to 12. Okay, well, a left Riemann sum, that's all about doing rectangles, right? So we're doing left Riemann sums. It's all about doing rectangles, which means we're going to be using base times height plus base times height plus base times height 3 times. And if we're doing from 0 to 12, the base is going to be 3 minus 0 times the height. Now the height is going to be you got to be really careful. Señoritas, I'm here all the way over here. So since we're taking the left Riemann sum, make sure you take the left value, right? Not the right value. So 100 plus the second rectangle. The second rectangle is 7 minus 3, that's the base, times the height, which is going to be 85, plus 12 minus 7 times 69. You do have a calculator in this question, so make sure to use it. This will give us a value of 985. Next, we're going to interpret the meaning of 1 over 12 times the integral from 0 to 12. That right there is the average value. We don't have to calculate it, we just have to interpret. And how do I know it's the average value? Because that is going to be 1 over b minus a, the integral from a to b of f of x dx. So the meaning, 1 over 12 times the integral from 0 to 12 of c of t dt is the average temperature of the coffee during the first 12 minutes. And if you want to calculate it just to be safe, it's not that hard. You guys have a calculator with you. C. Okay, we're given a rate of change for the temperature, C prime. Find the temperature of the coffee at 20. Since we're trying to figure out an actual value at a specific time, we're going to have to use the formula f of x equals the integral from a to x of f prime of t dt plus f of a. And we're doing this formula because we technically do have an initial condition. We know the initial temperature of the coffee, right? The initial temperature is 100 degrees Celsius. It's up on the table. You can scroll up to see it. So the temperature of the coffee at 20 minutes is going to be given by the integral from 0 to 20 of C prime of T dt plus 100 degrees Celsius. That gives us sorry, I'm mistaken. I got to backtrace a little bit. We're not actually finding the temperature from the beginning. We're finding the temperature basically starting from 12. So I got to change my initial condition real quick. 12, comma 55. And then my integral is going to be from 12 to 20. There we go. Plug that into the calculator, and that gives us 40.329 degrees Celsius. And again, I would recommend for you guys to make a sentence, not just give the number and move on. But because this is a video, I'll just get to the next question. Okay. We're given C double prime. Determine whether the temperature of the coffee is changing at a decreasing or at an increasing rate. This question right here is asking if C prime is increasing or decreasing. So is C prime decreasing or increasing? And that's going to be pretty straightforward. All we got to do is graph the function. Graph the function C double prime of T and figure out if it's positive or negative between 12 and 20. And I'll tell you exactly what it is right now. Between 12 and 20, C double prime of T is going to be positive, which means the temperature of the coffee is changing at an increasing rate. On 12 to 20. And we'll give a reason. We'll say because C double prime of T is positive. That's it. Okay. The next question we're going to do is going to be number 3. Once again, because that happens to overlap with A, B, and B, C. So both of you guys get to work on the same question. Dice, the depth of the seawater at a location is modeled by the function h and it satisfies the differential equation. It's known that h of 0 is equal to 4. Okay, that sounds like an initial condition to me. It's probably going to be useful. We're given a slope field and we want to sketch a solution through the point 0.4. So just go ahead and follow the slope field. And that's your solution. Part B. It can be shown that h of t is greater than 1. And yeah, you can actually see that from the graph, right? H of 1 is like right here. And then it is greater. Find the value of t between 0 and 5 where h is a critical point. Is it a minimum? Is it a maximum? Or neither? Okay. So I'm going to go ahead and do my work right here because I have some space. If I want to find a minimum or a maximum, we know that we're supposed to take the derivative and make it equal to 0. Okay. Thankfully, the derivative is already in factor form. So I'm going to go ahead and separate the factors. Each one of them has to be 0, or it could be 0. Now, the 1/2 technically doesn't matter. The 1/2 is a constant. So that's why I'm not writing the 1/2. H equals 1 is a critical point. This one, I'm going to have to find cosine inverse of 0. So think about your unit circle. When in the unit circle does cosine equal 0? Well, the answer is going to be at pi over 2. And technically, there's more answers, but I'm going to stick with that one for now. Multiply by 2, and there's your second critical point. Now, h equals 1. I'm going to say that it's going to be invalid since it does say that h of t is greater than 1. So we're only going to be focused on pi as the only critical point. Okay. Now, normally you want to take some values and plug them into your derivative, but you know what? Let's just go ahead and do it. H prime of, let's say 0. No, 0 is gonna be, we can't use it because it has to be greater than 0, right? So pi. Okay, that's gonna be a little tricky since our derivative is dealing with an h, as you can see right here, right? And I'm supposed to plug in t values. So the best, simplest way to do this is by looking at the graph that we did in part A. In the first interval, from 0 to pi, look at what's happening with the graph. The slope is positive. Then you're going to get to your critical point, and then after that, the slope is negative. So this is going to verify what we already see in the graph. It's going to verify that the derivative is, or the critical point is a maximum. Okay. C. Use separation of variables so that we can find a particular solution, and we are given an initial condition. Okay. This is going to be kind of a long one. And I'll do it over here. C. All right. dh dt equals 1/2 h minus 1 times cosine of t over 2. Okay, first we're going to separate the variables. I'm going to multiply both sides by 2, and I'm also going to divide by h minus 1. At the same time, I'm going to multiply by dt. Okay. Now think about how you would do it step by step if this confused you, all right? Okay, moving forward. The antiderivative of 2h minus 1, we're going to integrate. That's going to be 2 ln of h minus 1 equals sine of t over 2. And because the argument is a little more complicated than just t, I'm going to go ahead and take my derivative, which is 1/2, but then I'm going to multiply the reciprocal, right? So instead of 1/2, we're multiplying by 2. If that part confuses you, to go from here to here, just go ahead and do it by hand and do u substitution. All right. Now the initial condition, 2 ln of 4 minus 1 equals sine of 0 times 2 plus c. 2 ln of 3 is c. Okay. Now that we have our constant, we're going to go back and we're going to plug it into this line so that we can find like the final equation for h. Let me do it in a different color. 2 ln of h minus 1 equals sine of 2 over t over 2 Let's put the 2 in the front. Plus 2, ln of 3. All right. Divide by 2. Then you can go ahead and use E. Okay, we're going to do two things in the next step. We are going to add 1 to both sides, but we're also going to use the properties of exponents to separate this guy from this guy. So E sine of t over 3. Now addition came because there were 2 bases multiplied. Plus 1. E and the natural log cancel each other out, leaving us with 3e sine of t over 3 plus 1. And that covers question 3. One more question that AB and BC shared together. Number 4. All right. We have the graph of a differentiable function f. We have a horizontal tangent at x equals -2. All right. Let's see. Let's go ahead and put that. Horizontal tangent. The graph is linear from 0 to 7. Okay, perfect. And region R has a value of 12. The function g is defined by g of x equals the integral from 0 to x. We're going to have to find g of -6, g of 4, and g of 6. Okay. What's that here? A. G of -6. All right. Let's go ahead and use the integral given to us. The integral from 0 to -6 of f of t dt. G of -6 equals -6 to 0. Now, what is the area underneath the curve from -6 to 0? Thankfully, that's given to us, and we were told that it was 12. Now we're going to find g of 4. That's going to be the integral from 0 to 4 of f of t dt. G of 4 equals. Now, the integral from 0 to 4, we're going to find it by calculating the area of a triangle. So we have 1/2 base times height. And that equals 4. And then finally, we're going to find g of 6. Now, the integral from 0 to 6 uses the same triangle from part B, or not from part B, from the previous function, g of 4. And then we're also going to have to use a second triangle. We're going to have to use this additional area. Okay, and because that triangle is below the x-axis, make sure that you say that the area is negative. Come on, zoom in. It didn't want to zoom in. I was afraid this was going to happen if I started zooming in or moving my page. It shouldn't be that hard to zoom in. There we go, finally. Okay. Minus 1/2. The base is 2. The height is 1. That's going to give us 3. B. The function g at which Find the critical points for G. Okay. Well, G of x is going to be the integral from 0 to x of f of t dt. And if I want to find my critical points, we know we're supposed to find the derivative. Now, the derivative cancels the integral, leaving us with f of x. We set it equal to 0. And now tell me by looking at the graph, right? Where does the function f attain the value of 0? That happens at x equals 4. C. Now we're given a function h, and we're supposed to find h of 6, h prime of 6, and h double prime of 6. Okay. Let's go ahead and find h of 6. H of 6 equals the integral from negative 6 to 6 of f prime of t dt. And even though we don't have an equation for f prime, finding the antiderivative isn't that bad. The antiderivative, it's just f of t. Evaluate f of 6 and subtract f of negative 6. Now looking at the graph, f of 6 is negative 1 and f of negative 6 is 0.5. So this gives us negative 1.5. Okay. Now we're supposed to find h prime of 6. But before we find h prime of 6, we need to find the derivative. The derivative cancels the integral. So h prime of 6 is the same thing as saying f prime of 6. So we need to look at the slope of f at x is equal to 6. Now, if you look at the slope right there, we have a linear function. So the slope is basically just going to be the rise over the run. And once you calculate that, it looks like for any given point, the rise is going to be negative 1 and the run is 2. So we have negative 1/2. Now, one last one. H, we got to find h double prime of 6. Okay. This is where we left off previously. So my second derivative is going to be the second derivative of f. So h double prime of 6 is going to equal to f double prime of 6. The second derivative is talking about concavity. And a linear function, that one has no concavity. So h double prime of 6 is 0. Just because it's a linear function, right? It's staying very constant. And that right there covers the 3 questions that come up in both in the AB and the BC packet. Next time, I'll do the questions specifically for BC. Thank you.